Imagine a person pushing a box into and across a rough floor. Will the box speed up, continue to move at the same speed in the same direction, or will it slow down, or I have no idea. Easy peasy, since the floor is rough, it's definitely going to slow down, right? Really? Let us find out more. Hi, welcome to the School of Success. Since you probably clicked on this video because of the title, you know that we need to understand Newton's second law in order to determine the fate of that box. So let's examine what wise old Newton discovered. Sir Isaac Newton discovered that if a mass was to experience an external resultant force, the rate of change of momentum is directly proportional to the resultant force. As momentum is equals to mass times velocity, we can express Newton's words into an elegant formula, which is as such. Do note that the triangle symbol represents a Greek alphabet, which is also called delta. Sounds really cool, right? And we use delta to represent change in physics and math. As mass remains unchanged in most scenarios, we can simplify the formula into this. Now, we can infer that component to mean the rate of change of velocity with respect to time. This is none other than the definition of acceleration, which we have learned in the topic on kinematics. Hence, we can now arrive at this beautiful formula, which is Fnet equals to ma. Fnet also means resultant force or net force. That's where the net comes from. And we would like to use the abbreviation Fnet instead of Fr. How to find Fnet? We do not use the term total force because total suggests a simple addition of all the forces. But we know that force is a vector, and hence the direction of the force can affect the end result greatly, and therefore we are more concerned about resultant force than total force, which is the blind addition of all the forces. We can find resultant force by taking the sum of all the forces in one direction and subtract it with the sum of all forces in the opposite direction. If more than one dimension is involved, vector addition will be required, and we can do that either by doing a vector drawing or by resolving the forces. Having some issues with vector addition? Let us know in the comment down below and we will do our best to cover that content. Now that you have a clear understanding of what Fnet represents, what can we interpret from this simple formula? When it comes to physics, I love to emphasize how amazing formulas are, as it not only beautifully summarizes a whole chunk of words from the definition, it can also tell us a lot of story if you know how to approach them. So we are going to dive into that right now. Firstly, examine the variables involved. From the formula, we know that if there is a resultant force, it will cause a mass to accelerate, hence ma. And by the term accelerate, we will be expecting the velocity to change, either speeding up, slowing down, or changing in a direction. What does this also means is that when the same net force is experienced by two different objects of different mass, the acceleration the object experiences will change as well, meaning that if the mass is heavier, then the corresponding acceleration should be lower. Do also recall that force is a vector, and the direction of the net force will determine the direction of the acceleration. Now, if we were to consider the formula from another angle, it also allows us to infer that if an object is accelerating or decelerating, is experiencing an external net force. This means that the forces acting on that object is not balanced. If the velocity of that object remains the same, meaning that there is no acceleration, this can be the case where the object is either moving at a constant speed or is stationary. If we were to sub a equals to 0 into the formula, we will get Fnet to be equals to 0. And from that, we can infer that the forces that is applied on the object is actually balanced. With this, we are now ready to bring back our box. By applying our understanding of Fnet equals to ma, can you determine if the box is going to speed up, slow down, or remain at a constant speed in the same direction if it is going to be pushed into a rough floor? Let's see if you can answer this question in 5 seconds. Have you gotten an answer? The answer is that it is impossible to tell. We have learned that in order to determine the state of motion of an object, we need to first find out the resultant force that's acting on the object itself. This can be found by drawing a free body diagram. A free body diagram consists of all the forces acting on the object, and in this particular case, there are 4 forces acting on the box. Pause the video right now and try and sketch that out. Alright, now let's check your answer. Firstly, the weight, which is due to the effect of gravity, should be acting on the box. Oh, I should have made it known that it is happening on a planet with gravity. Sorry, I assume. And we will label that weight W. Since that we know that the box is not going to lift off or crash through the ground, the vertical components of the forces should be balanced. The force that balances off the weight is known as the normal, and let us label that with the letter N. With the vertical forces out of the way, let's move on to the horizontal forces, which are the more tricky ones. In terms of the horizontal forces, we have a pushing force due to the person, which is going to the right. Let's label that with a capital letter F. Since it is mentioned that the floor is rough, there is an additional opposing force at the base of the box between the surface of the base of the box and the rough floor. And yes, you got it, it is none other than friction. We are going to label the friction as Fr. This is also the reason why we do not label resultant force as Fr. Do note that friction occurs between 2 surfaces in contact, hence the arrow should be drawn right there. Now that all of the forces have been identified, the outcome of the motion of the box greatly depends on which of the horizontal force is bigger. As most people may intuitively think that the box will come to a stop because there is friction, that is due to the assumption that the magnitude of friction, Fr, is larger than the pushing force F. In this scenario, the resultant force is in the opposite direction as the initial motion. This caused the box to accelerate in the opposite direction and hence causing it to slow down, meaning that it will decelerate. However, it is also possible for the friction force to be equal, if not even smaller than the pushing force, right? In the event that both forces are equal, the net force, which can be found by taking the pushing force, subtracting away the frictional force, will give us a result of 0 newtons. Fitting it back into the formula, now MA will be 0 newtons. Since the mass remains the same and cannot be 0 since there's no substance lost from the box, acceleration has to be 0 meters per second squared. In other words, the box will now move at a constant velocity, meaning in the same speed in the same direction, as all forces on the box are now balanced. In the event that the pushing force is still bigger than friction, there will be a net force in the direction of motion of the box. This will cause the box to accelerate in the direction of the pushing force. For those who are wondering about the difference as compared to motion without friction, we can go back to the formulas to examine that. Without friction, Fnet will be equals to F, and which will be equals to MA. However, with friction, we need to subtract away Fr from F. And since M remains constant in both cases, we can identify that there will be a smaller net force due to friction. And that in turn will result in a smaller acceleration for the case with friction. With this, we come to the end of our simple lecture plus practice on Newton's second law. We hope that you have gained a deeper understanding and more confidence in content and also its application. We also hope that you have a better appreciation for physics formulae and how much information can be derived from them. For those who are frightened by the math, take your time to appreciate it, and this will be one of the skills which you gain once and you will be able to make the rest of learning of physics a lot easier. As a quick tip, use the buttons J, K, and L on your keyboard to play back 10 seconds, pause or fast forward the video a few times. This investment in time and effort will be definitely worthwhile. As we are a growing channel, your support will make a huge difference. Hit the like button if you haven't already. While we have a whole series of content lined up which we can't wait to get into production, we also want to make sure that we can give you the timely support and help you need. So do share with us what content and support you would like to see here on our channel in the comments down below. Be a great friend and share our video or website on your social accounts. Don't forget to visit our website for some downloadable content and also to get help by submitting your questions on our bulletin or help others by offering solutions to their problems which they posted up there. Subscribe for more educational content and we will see you in the next video. Cheers!